So we don't have any new notes today, right? It's just more practice on trig identities. And I thought it would be helpful, if you want, that I could do the homework with you, slash for you, slash after you've done it, you could check it, right? So trig identities are basically using the rules of trig, which we know. This is obviously punched out. That's tan is sine over cos, and cotan is cos over sine, 1 over cos, 1 over sine, and then we have our three main Pythagorean identities. So when we ask you to simplify, basically the strategy is to change things to sines and cosines. And I often drop out the theta. Oops, that's 1 over sine for cosecant, and then 1 over cos. And then you use your just math instincts that tell you when to cancel. You might be like, wait a second, we did that one already, right? There's only so many trig identities, so we recycle them. So that's actually kind of comforting because you see something and you're like, hey, I did that before. You can always use these identities. As long as they're not asking you to prove them, I can say, well, 1 plus cotangent squared is cosecant squared. Cosecant squared is 1 over sine squared. 1 over sine squared is sine squared. And that's fine to just know that. You could write it out if you wanted to. It's 1 divided by 1 over sine squared, which is 1 times sine squared over 1, which is sine squared. Next one here, this is obviously getting a little trickier. Let's see. Sine squared minus cotan is cos over sine, tan is sine over cos. So I believe that that's just going to cancel out. And then here I have cos over sine times sine. Here, these are going to cancel out, and it's just going to be 1. And then here, this is going to cancel out, so I just have cos in the bottom. Now, sine squared minus 1, this is a little tricky. If I come back up here, I've got to visualize, if I subtracted 1 from both sides and moved this to the other side, do you agree that sine squared minus 1 is the same thing as negative cos squared? It's not something we usually do, but I'm going to see that here because I see the sine squared minus 1. So I'm going to make that negative cos squared, and then this is just cos. So obviously one of those cosines cancel, and I get negative cos. And that's a little bit tricky, but that's how you do it. Here I have cos in the numerator. Secant is 1 over cos minus tan is sine over cos. So I have cos over 1 minus sine over cos. I might do the whole like divide here thing, like it's this divided by that, so it's the same thing as cos times cos over 1 minus sine. Oh yeah. There might be an easier way to do this one, but this is what I'm going to do. Cos squared over 1 minus sine. Now back to this trig identity. Cos squared is equal to 1 minus sine squared, right? I can move that to the other side. So this is 1 minus sine squared. And that's a really hard step. But once you see that, then you might remember that we can factor that. And how do I factor 1 minus sine squared? You're right, it's 1 minus sine, 1 plus sine. So then the 1 minus sines cancel, and I'm left with 1 plus sine. Now, I think both of those last two, I'm going to go back and put a star by number 4 and a star by number 3. Those both had some harder steps in them. If I was going to choose one for the quiz or the test, I would probably choose one like number 1 or number 2. But nonetheless, it's good to know, right? Good to know. Then when we see the verify problems now, this is when we're drawing the line. We can't cross the line. We've changed this now from a theta to a beta. Okay, fine. Maybe I'm just going to distribute this as is here for a second because I'm going to get tan times cotan plus tan squared. Well, isn't tan times cotan? That's just going to be 1, right? Sine over cos times cos over sine. So I have 1 plus tan squared, which if I look up here, 1 plus tan squared is secant squared. So I have secant squared beta. So I got it there. So that's right. Smiley face. Let's see. Here, if I put a line down here, 1 minus cos squared, I know that that's going to be the same thing as sine squared. Again, for my spin-off, I'll add the beta. And then here, tan squared is sine squared over cos squared times cos squared. That's going to cancel, so I'm just going to get sine squared. And it's fine to work with each side, right? So I simplified this side, I simplified that side, and now those two sides match. Some of these are going to be ones you've seen before. I feel like this might be one of them. I don't know. I'm going to work with this side really quick, although I might not be able to really do anything past that. Here, if I have cotan, which is cos over sine, and tan, which is sine over cos. So this is kind of that classic situation where we get a common denominator. And the common denominator is sine cos. So that fraction needs a cos, that fraction needs a sine. So now I'm going to have cos squared plus sine squared over sine cos, right? But what's cos squared plus sine squared? 1. And I'm okay to like say that those match now. 1 over sine cos and 1 over sine times 1 over cos. But maybe I'll just do this just to make them totally match, right? Ta-da. Common denominator. This one has got a tricky step in it, but once you see it, I think you'll be okay at it. It's got a common factor. So the common factor is cosine squared, and I'm going to pull that out. I'm left with 1 plus tan squared, which I know from up here is secant squared. So I have cos squared times secant squared. But secant squared is 1 over cos squared, right? So that's going to cancel, so I'm just going to get 1. And now I got it. So again, common factor, then used my identity, simplify from there. Here, let's see, everyone's just its own little puzzle, right? 1 minus cos squared. I always keep going back to here and kind of visualizing, oh, right, if I move that to the other side, 1 minus cos squared is just sine squared. So I have sine squared over cos, and now I'm kind of stuck. So now I'll come over here and be like, okay, tan is sine over cos times sine. Hey, sine squared over cos. That's it. Done and done. The last one here, let's see, if I distribute sine times cosecant, and I'm fine if you're like, sine times cosecant is 1 because the sines cancel, or you can write that out if you want. 1 minus sine squared. Again, from our Pythagorean identity, if I move sine squared to the other side, 1 minus sine squared is cos squared, and then I got it. And I should put the alpha in there, cos squared. I'll do the back too. So back is a more verify, and these are some trickier ones. And sometimes there's like different ways. Like you might think like, oh, common denominator. But if I really like look at it, I might want to do this first. 1 over cos squared is cos squared. 1 over sine squared is sine squared. Cos squared plus sine squared is 1. It wouldn't be wrong to get a common denominator. You would get the same answer. Here's, let's see, secant plus cosecant. This one looks hard. So I got 1 over cos plus 1 over sine, and I'm just going to make this 1 over 1 and sine over cos. Now I really like this one because this is taking us back to when we did rational expressions and we did complex fractions, and we learned that you would have to multiply each fraction in a complex fraction by the common denominator, right? So we had a cos and a sine and a 1 and a cos. So the common denominator is cos sine. I'm going to multiply everything by that. This is going to cancel, I get sine. This is going to cancel, I get cos. I'm getting a little nervous here. And here I have cos sine, right, plus sine squared. Oh, I see it. Now I might get stuck there until I notice in the denominator I've got a common factor of sine. So I have sine plus cos in the numerator. If I factor out a sine, I'm going to have cos plus sine left in the denominator. And we should know that sine plus cos, cos plus sine, same thing, right? Commutative property of addition. So I have 1 over sine, so I have cosecant. A tougher one, but we got it. Complex fraction, factor out the denominator, good to go. cos squared, now this is going to remind me of the one we did on the front. And I just know this because we just did it. I'm going to replace cos squared with 1 minus sine squared. And again, I can do this because of this. By the way, people ask a lot, are these given to me on the quiz? They are not. These formulas are not given to you on the quiz. So I would recommend just memorizing this one. And we know that every other one is just some kind of spin-off of the main one, including that cos squared is 1 minus sine squared, which then factors 1 minus sine 1 plus sine, which then cancels, right? Which then gives me 1 plus sine. And again, we know that that's a tricky step, right? But once you've seen it, you're more likely to get it the next time. The next one, I recognize a trig identity right off the bat. I recognize that tan squared plus 1 is secant squared. So even though it's written 1 plus tan squared, I know that that's secant squared. Secant squared is 1 over cos squared. Cosecant squared is 1 over sine squared. When I divide, I flip the fraction, so it becomes sine squared over cos squared, which is tan squared. Right? Almost there. This one I'm going to put a star by because you haven't seen one like that yet. But I don't know, maybe you'll recognize it, like cos to the 4th minus sine to the 4th. Let me give you a hint. It rhymes with tractor. Rhymes with tractor. You are right. We factor cos squared minus sine squared, cos squared plus sine squared. So cos squared minus sine squared, don't know what that is, but I know that cos squared plus sine squared is just 1. So it's just cos squared minus sine squared. Ta-da. If you're still stuck on that factor step, think about it if it was x to the 4th minus y to the 4th, x squared minus y squared, x squared plus y squared. And you might say, well, doesn't that factor? Again, it does, but I just got it to match the other side, so it's fine. This one I feel like we had in the notes the other day where you do have a common denominator of 1 plus sine, 1 minus sine, 1 plus sine, 1 minus sine. Again, I'm just working with that side. So I'm going to distribute kind of as I go. So I'm going to get cos minus sine cos plus, if I distribute there, I have cos plus sine cos. And it's all over this 1 minus sine, 1 plus sine. Well, here that's going to cancel. And I have cos plus cos, which is 2 coses. And if I FOIL that back together, now I have 1 minus sine squared. Always comes back to this main Pythagorean identity. 1 minus sine squared, if I move that over, is the same thing as cos squared. So I have 2 cos over cos squared. One of the coses is going to cancel. 2 over cos is really the same thing as 2 times secant. And there you have it. There you have it. So one question I get a lot is, how much work do we have to show? And my answer is always, show on the quiz or the test as much work as you would want me to show on an answer key. So if I skip steps and I say, well, you know, everyone would understand this, if it's not everyone always doesn't. So if there's an explanation that you would want to see on a really clear answer key, that would be the steps that you would need to show. And there you have it.